Okay, this is the program I've been working on lately, which output, this console output, seems to demonstrate my lottery ticket concept very effectively, or generates lottery ticket, what I'm calling lottery ticket, very effectively. And so, what this program does is it trains networks, a pool of networks. There's a pool of 2,000 networks. It does 10 model generations. Each model generation it trains 10 times with a network. Trains a network 10 times using stochastic gradient descent. This is the learn rate. There's no regularization. The network has a square size of 16 by 16, an input size of 25, an output size of 14. It has one category of output for XOR, and this XOR has 1,400 training samples of this XOR function that it's going to try to learn. So the first thing I did was I initialized this pool of 2,000 networks to a random state that has been he or K-mean scaled, and then I printed out the pool. And then it's printed, sorted from best, fewest misses to most misses. And you can see the last network in the pool. This is its ID, network 430. This is the 430 network generated. Has this measurement, a radius, which I'm going to describe, of 10. But what we're really going to look at here is misses. It has misses of 917. And so it has a magnitude of 23. That's the magnitude of all the weights in the network. So I'm going to scroll up on this output and we can examine the distribution of misses of completely randomly generated networks. So you're seeing a lot of 700s here. From what I understand so far is that in this case, the majority of them, if not all of them, it routes the XOR to either high or low, but not both of them. So all of the outputs are routed to either high or low, and there's no outputs that route to either one. It's all one side basically. So we're scrolling up. We're getting the best network is 482 misses. Completely random state. It's got a radius of 86. Radius is the square root mean squared error of all the training data. So of the 1,400 training data, it takes the root mean squared error. In this case, it's 86, which is a lot. And this best network had 42 misses. Its ID was 457. Okay, so this program, it takes about a minute to run a model generation. So I'm going to run the first generation. The data's just been initialized, and now it's training 10 times on these 1,400 training samples. So each of these dots is when a network completes training. So there's going to be 2,000 of these dots. And in the case where a network generates an infinity, it stops being normal, it'll output a bang. And last time I ran this program, there's actually a bang outputted in here, but we'll see if one outputs this time. Okay, model generation just ran. It's printing out the networks, and we're going to see what we got when we get to the bottom. So the worst network after 10 training has 858 misses. It has a radius of 1.7. Its network 1271. It's got a magnitude of 23. Okay, that's the worst network that you could get after training 10 times. Let's see what the best network looks like. I scroll to the top. We're already out of the 700s into 600s, so these things are actually training to some extent. So after 20 trainings using Stochastic gradient descent, the best network has 243 misses, radius of 1.4. This one has a smaller radius, but more misses. Okay, let's go to the bottom. So you could have gotten that network, or you could have gotten this network. 858 versus like 243 after 10 trainings. So what I'm going to do now is what happens now is all of the networks that trained that did not have at least 400 had a maximum of 462 misses, they're re-rolled. So there were 1908 of those networks that's going to completely re-roll. So it kept around 92 networks. 92 networks were smaller than 462. So it's running another model generation. Let's see what generation 2 is going to look like. So in this model generation, there are some 92 networks that have already been trained 10 times, and they're still in the pool. But now, additionally, there are 1908 new networks in the pool. And so this is the second model generation. Okay, it's printing out the distribution. So even more scoring networks have been found this time. The worst network, which was just generated, was 865 misses. The best network, which just generated, had was quiet. Has a radius of 1.31 and 159 misses. This network was generated. Fred. This network was generated in the recent generation, and it beats the second network. 647 has ran twice. This network has ran twice. This is also a new network. So there are a bunch of new networks in the top 10. The top 10 is 286. The 300s start at 15. So let's run another model generation. So I'm thinking about putting this program on GitHub if anyone's interested. There's a bang. So one network finally generated an infinity. And so that network popped. It's nothing anymore now. It's going to be regenerated. Okay, new generation. Worst network, recent generation was 864. Let's see what the best network was. $183. The best network got a little worse. Let's see, the top 10 network, 266. The threes start at 28. Anyways, this is demonstrating what I call the world of lottery ticket. Alrighty.